Welcome back. Magloop. I forgot about the Magloop for quite a while. Didn't do anything on it. Yeah, I got a bit tired of it. We'll be having a look at some things I've done on it, which I'll introduce now because I'll show you the finished product first and then we'll go into the background of it. So I'll see you in a minute when we come back having had a look at where I'm up to with it. And I started to get a bit frustrated with it, to be honest. We had this box which just serves to have the two coax cables for the main loop coming in, and we want to be able to tune that main loop with a variable capacitor. And originally I had one of these little tiny motors, 5 volts, and yeah, it's a stepper motor, but it doesn't produce much torque. Because these capacitors, this is actually the second one, this is the original one, these can get a bit clunky. That one is actually very loose. This one, I can't turn it by hand at the moment for reasons you'll see. So what I did was I elected, let's see if I can zoom out. What I did, I elected to get a NEMA 17 stepper motor. And I'm aware these are used on 3D printers, ordinary printers, such like many things. And I made a slightly bad decision because I bought an ordinary one. And when I tested it, I know you can do micro stepping, but before I got to that, before we go anywhere near micro stepping, it worked out that by connecting that directly to the capacitor, it would only move in 1 degree steps. So I thought that was a bit too coarse adjustment. So what I elected to do was to buy some gears and stuff. And if I can just focus, the camera is on the end of a precarious lit tripod. So we've got a 60 tooth gear here, and I think it's a 12 tooth. I could be wrong, I'll double check that in the comments. So yeah, so we've got a more powerful stepper motor now that can work in 4 pulses and control the motion, has a bit more torque about it. It's very ramshackle at the moment. I'm just testing the idea. This perspex shatters if you look at it. You know, it's awful stuff. You can see here where it's shattered when I've tried to drill a hole in it. The capacitor is precariously mounted on cable ties, and there's a circuit board stuck on the end of it. Circuit board. So I've actually stolen temporarily. I couldn't find a single board computer. I couldn't find a microcontroller that would work with the Remote XY app. Had problems with the Wi-Fi and Bluetooth and all sorts. So I stole the one out of Brainwave, and having tested it on a bit of the usual prototyping breadboard, I've now moved up and put it on Vero board. And yes, I've cut the tracks on the Vero board to isolate them. And I've put this little NEMA 17 driver board, just tied in a knot through some holes for now. If I decide to build this properly, I'll move it all onto a proper PCB perhaps. And it's all powered by a little brick power supply that is designed for something completely different. But it's 5 to 12 volts DC. Not sure if that's 1 amp. I'll just tell you somewhere. Yep. So it's got an adjustment switch from 5 volts, 3 volts, 4.5, 6, 5, 6, 7.5, 9 and 12. So I'll plug that in, and that's supplying 12 volts. 12 volts comes in here. 12 volts goes into a 780, well, the 12 volts itself goes directly to this, which gets remarkably hot, and it then goes into a 7805 regulator, comes out the other side as 5 volts. That then goes into the microcontroller, and then the microcontroller reduces it again to 3.3 volts. Luckily, the 3.3 volts coming out of these 4 outputs is perfectly enough to drive this NEMA drive panel. So let's have a look at it. Now that I've made some further software changes, one of the things I found is when you first turn it on, there's no drive to the motor, it's not locked in any position. So it's very easy to manually turn it to where I've defined the 0 point as when the vanes are closed, so that it keeps it free from dust. Otherwise, if you're going to transmit, you may have problems with it arcing if you have any dust in the vicinity. Another thing I've done, the onboard LED on the ESP32, when I first turn it on, that's going to flash until it receives a signal from the remote control. So the remote control says disconnected, and now it says connected. So I've also added some more buttons on to give me a greater range of control. So we'll put this down here, on this handy little stand. And what I'll do, I'll tune through and see if there's any reception, because there wasn't a minute ago. So we've now got 3 speeds, so we can increment by 1. And you notice that the LED on the board shows green when it's going up, red when it's going down, and it just gives me a visual indication that I'm communicating rather than trying to see if this has moved. So let's just wind it forward somewhat. And it's going to be a typical afternoon where there's no reception. I did try it before. Let me see if there's anything on 20 metres. That's on 40. Oh, it is on 20. Okay, we're now on 40 metres. I'll just scan back down and see if we get anything. We've also got this position number now on the display, which means that if you make a note of a particular frequency, I mean, I do a lot of FT8, so it'd be 7074 megahertz, 7.074 megahertz. I don't know if you heard the increase in noise there. So it's literally about 10 steps from one side of the FT8 signal to the other, and it's only about 2.5 kilohertz, 3 kilohertz wide. So ideally it could be a finer adjustment, but I'm going to play with this and see how I get on with it. But that's what we're up to now. It still does this chun ring thing sometimes. So I need to do some research into that and find out why it happens. But I thought you'd like to have a look at that. That's pretty much, it's only a demo version at the moment. I don't know if it's going to be a problem having the circuit board inside the loop. You should be able to tune it on receive only and then just tweak the SWR maybe. But in an ideal world, this would all be encased and underneath the loop, but I'd then have to back on by some more wood. So there's FT8 chun ring away. We should be able to do something useful with this. I don't know what happens there. Maybe there's some stiffness in the drive, but I can play around with it. I've got the basics down, which is what I really wanted to achieve. The switch on the side here allows me to vary the tuning range. So I'm adding an extra capacitor in, and these are all things With the Magloop, somebody on one of the forums said, no, that's wrong to somebody else's Magloop construction. And the point is, there is no wrong. There is no rule. It depends what band you want to attempt to work, what power you want to use. I've left the box open. At the moment I'm only using the outer connections, but you can configure it like a Mobius loop by linking one inner to the other outer. You can make it in all sorts of different configurations. And that's why I've used these cheap plastic boxes. It's very easy to add a switch to change the configuration over, or a relay and add some more outputs onto the ESP32 to switch the configuration remotely. And then you're going to run out of space on this controller. But I'm sure we can find a better one. And generally, if you know you're going to work a certain band, it's no trouble to go and press a couple of switches, unless it's at the other end of the garden, which in my case is not very far because it's just beyond. Which is not very far because it's just beyond the window. So yeah, I'm not sure about the stability issue and the fact that the regulator gets stinking hot. But onwards and upwards, as they say. We'll see what happens.